All right, I've started the recording, Sanjeev. I think we've got a few questions. All right, Shweta has got a question. Okay, Shweta, you can ask.
Yeah, so regular process. Let's ask some questions if you have that you have been working on so far, and we can then we can then get into today's agenda. You have to come on screen, preferably on camera. I am unable to
unmute. Okay.
I think you should be. I have given permissions. People can unmute themselves. Can anybody unmute himself and confirm that this is working?
No, Sanjeev, I don't think anybody can.
Okay. Try now.
Yeah, it's working now.
Cool. Just setting at two different places. All right. Now we have good participations. 32 now. Yes, let's quickly ask some questions from the previous meeting, and then we can proceed. Shweta, is it fine now?
Yeah. So can I ask now?
Yeah, please. Yes.
So my question is not to you, to the other teacher. So he posted on YouTube a project on Jenkins CI/CD pipeline, and he said like you can comment your email ID so that he'll send the PDF. But due to some security purposes, I'm not okay to posting my email ID on YouTube comments. So is that okay if I post my email ID here, and can you email me the PDF?
You can reach out
Yeah,
to
you can do that. You
Yeah.
you can reach out to me on WhatsApp. Do you have my WhatsApp?
Yeah.
Okay.
Okay. Yeah, thank you.
Yeah, I'll send it out.
So like remember that what we share on YouTube usually is meant for everybody. Like sometimes it's for junior people as well. But what we discuss in mentorship is usually slightly complex.
Yeah, and don't trust everything that you see on YouTube. So you, yeah, it's not a very professional grade project. So it's just a very basic project. So, but what we do here in mentorship is enterprise grade, and yeah, so there will be a difference that you see in the document. And sometimes we do pick it up from internet. So some of the contents may or may not be verified. So yeah. But it's different story in the mentorship. But I will post you. So send me on your WhatsApp, and I'll send you the document.
Any other
Okay, sir.
question before we proceed for today's agenda? All right. So let me share my screen. You guys can see my screen with full screen part 4, right?
Yes, indeed.
Okay. So what we want to do today, my agenda for today is to look at various options, how any organization can set up their infrastructure in different cloud regions, multiple regions, etc. So far, we have seen at high level how to create different AWS accounts, how to use governance, how to deploy very basic VPC kind of infrastructure across different regions, making smart GitLab based pipelines, or you can use any other tool if you want to, other than probably Jenkins is suitable. So now we will go into that. We have a basic infrastructure. We have a VPC available, but what next? Within a specific region, what do we do? and how do we connect those different regions so that my customers can reach my product, my website. So we'll look at some of those strategies today. I don't want to limit it to one or two such scenarios, and then all the concepts are not clear to people. So we'll look at various options that are possible. There could be multiple such options in AWS, and we'll also try to see which one to select in which scenario. So if you can take some of these learnings from this session regarding multi-region deployments, when to use, when not to use, those sort of things, then they will be helpful in your future discussions. Let's first of all understand what is AWS network. You would have probably seen some of these slides in different color and other stuff. So basically, it tells that there are multiple AWS regions defined in these are the regions in yellow color. So they are in Africa, multiple of them in US, East, West, and then Europe, UK, there are multiple of them, Middle East, then India, then Asia Pacific side, and likewise Australia. So there are multiple such regions that AWS provides. And then there are some sort of edge locations that sometimes, like for example, the user is somewhere here in Africa, or is somewhere in China region somewhere, which is slightly away from the region itself. Then the AWS offers some sort of edge location, which is you can consider it as a sort of smaller data center, but very close to the customers where possible. So when we are setting up our application on AWS, it's not always that an region comes into picture. We deploy into certain regions, but we have other closer locations as well. Those are called edge locations. Now, what happens is some user is here. If the edge location is close to him, then he will first connect to the edge location, and then edge location will then route his traffic to the actual region where your services are. Or it could be first this and then this, instead of it going directly to this. Or if your services are not in this region, they are entirely you have hosted here, then this user can, if this is better response, then this can also go here. If this region is not at all hosted. So this is how users, the expectations, or how companies should plan their infrastructure is how many regions they want to deploy, and how those routing has to happen. Now, when we are buying or when we are setting up on AWS, it's not just the AWS EC2 instances and the compute and Kubernetes cluster and all that we are buying. These all edge locations are connected. These all regions are connected through AWS network backbone, which means under the sea or somewhere across different regions, these things are connected. May not be necessarily a straight line. It may be a sort of variable arrangement, or it could be using an ISP or some local provider. It goes to here and then here. So those kind of things, that everything is actually connected in nature through AWS network. At the same time, these regions are also connected using internet also. So internet, for example, might be probably taking a longer route and different variability. So it may be going through different channels and different stuff. So that's how it's connected. It's connected via AWS network, and it's connected via public internet. What public internet does is that it sort of brings variability in your entire infrastructure. So if Australia is connected to, say, Africa, it may be going like this and then going like this, or maybe some other channel. If something happens, first of all, this variability is like very dynamic in nature. So if I host my app here and I try to call from Sydney, the response that I will get will depend on how many hops I'm making and the response time would depend upon how this public internet is behaving at that point in time. Sometimes this may be broken because of some political issue or some other reasons or some disaster in that space. Then I will take another longer route to reach that specific region if I'm going via public route. So it's very variable in nature. You will still be able to reach, but the time you cannot commit to your users that, okay, it will be 2 milliseconds or 5 milliseconds or 10 milliseconds or 10 seconds or 10 hours. That is difficult to confirm. But if you are using AWS backbone, you may still be using these different locations, but at least you can confirm a consistent response. So if you are getting a specific response with AWS today, there is a very good chance that you will be getting the same response time tomorrow as well. Because once you enter AWS region, then your response time is sort of confirmed based on that. So usually the idea when we are designing app is that let's enter the AWS backbone network first, and then we start using AWS network. Then our response time can be measured and can be confirmed to my customers. So I was thinking like how can you relate to it? Something like when we are going for a pizza or some other such service at a shop, we are not only paying for that pizza cost, but also there are standardization that they bring in. If I order a specific thing at a Pizza Hut in Australia in one branch, then I would get a similar sort of experience if I'm ordering at another place. So they bring sort of standardization. Your response time probably will be similar. Your the quality and quantity will be very similar what you get. So people like that kind of approach when they know that this is what I'm gonna get. If you are going through internet, it will still work. It will still be a pizza, but it probably won't be consistent in nature. It could be very different. So that is the sort of difference. Once you enter AWS backbone, your response time and the quality and throughput is confirmed to you. And that's why the idea is that you reach an edge location that is closer to your customer, and the customer access the edge location and then to your region. That is the concept that we will try to work on during this session, and we'll see what AWS services and all, how we can do these kind of activities. Okay, so what we will discuss in today's session is some sort of networking services in AWS, because we are looking at deployment strategies in AWS. So I assume that you guys would probably know what regional services are. Regional services are like you define your VPC network, which we already did in one of the demo, and it's pretty standard. Like you define that this VPC is in Australia, US, UK, whichever region you want to. And then within that, you can define your load balancers, could be ALB or NLB, and it will always have like a region specific stuff. So that's why I call them regional services. These are some of the networking services, how you connect. So VPC, there could be VPC peering across different regions. Those basic concepts, I'm sure you guys are very well aware of. Routing also within one specific region, you can configure ALB. Behind the ALB, it could be a EC2, it could be auto scaling group, it could be Kubernetes, it could be Lambda function, it could be anything behind this. That will be in a specific region. These are regional services. Now look at some global services, because we are looking at deploying applications across regions. That is our agenda that we want to learn. So there is a service called CloudFront, which is popularly known as a CDN service. Then we have AWS Global Accelerator. Then we have Route 53, which is sort of domain name plus routing the regional traffic. So this service has two different flavors and two different configurations. We'll look at these things. So these three services can be used to route traffic to your different regions, basically. So we use one of them or multiple of them, and we deploy these in different regions, and then we configure some sort of connectivity between these two. And we'll look at why we don't need to do this, why we need to, do certain such stuff. The idea is that these services are running close to the customer. These are sort of edge services, we can say, which are running in near the edge location, and you can then get your traffic, get your customers into your network, and then route traffic to your regional services. Let's take a look at the first basic, simple sort of deployment. I think we saw this in action last week as well. This is my user, and it will say access a Route 53 record. We did a record, created a website last time, so that's DNS. It will reach out to CloudFront, and our origin will be an S3 bucket, and we will use an ACM certificate. That's how our website will be accessible. It's a basic static website kind of setup. Let's see if I can show you a very basic thing that I partly did last week. And just trying to log into my AWS console. I'm in one of the account in prod account, basically, that we have created through Control Tower and everything. It's prod account in the hosted zone. If you remember, last time we created a hosted zone for this website. And this is a CNAME that we have created, www.DevOps Cloud Labs. And this is pointing to a CloudFront distribution. So if I just hope it works. Okay. This static website is sort of secure in nature. We have a certificate created for this. If you remember, we created certificate last time and issued by Amazon. And that's how you will see it's being a secure website. How we do it, the static website. This is a CloudFront distribution that I created. So eventually when you create one, it takes quite a bit of time, 10-15 minutes, any of this edge location services. And I'll say use a SSL certificate that we created last time. And I will set origin as my bucket. Basically, it has S3 static website. That's how this architecture is achieved. The Route 53 record pointing to a CloudFront distribution, which is using S3 bucket as an origin and also using an ACM certificate. So that's how it is. The behavior is pretty much standard behavior. We haven't changed any behavior in this. We'll look at what this means later on. That's very basic setup. And that's how we reach to this website. So we are using Route 53 pointing to this distribution, which is then pointing to S3 bucket. S3 bucket has an index.html, which prints this value. This is static website with HTTPS. You can find multiple of videos online that you can see. Because I have seen like a lot of small startups will start with sort of static website being one of their product. As things start to grow, we look at other arrangements. We still use the Amazon CloudFront as our distribution, but we can probably have a different bucket for S3 content, for HTML content, and we might have a different bucket for my images and CSS and JavaScript and all sort of things. And I can configure something like a path-based routing, that if my path has slash certain URL or something, then I can use a different bucket. And if my CloudFront distribution has like slash images, etc., then I can use a different S3 bucket. But to do this sort of setup, I have created a couple of S3 buckets. I'll show you what I have done. It's very similar to what we did a static website, but we have distributed across 2 different buckets. So I have this was my static website. Now this is my HTML only bucket and image only bucket. So this image only bucket has this one specific logo, and this is my HTML only bucket, has my index.html. Now you will see that for a static website to work, last time we did was that we made a bucket public. Now, a lot of time this is not desirable, that you don't want a bucket to be public in nature. You want the bucket to be sort of private. Objects can be public, but you want to manage it through certain policies. So we'll look at the CloudFront distribution. So this is my example of mixed images plus mixed sample, which has images plus HTML. So I have created this distribution. So this is a different domain name. And here I have created 2 different origins. What I have done basically is, if there is another third sort of thing, then I can set up an S3 bucket, configure that I want to do, my origin should be this bucket. And usually if you see the origin access, how you gonna access the origin, how you gonna access your S3 bucket? Should it be public? It's not recommended making it public. You can use something like how you gonna access that, and then you can copy a specific policy, apply this to your bucket, which I have already applied. So basically I have applied a specific bucket policy, which says that basically this specific CloudFront distribution should be able to get objects, anything into the HTML bucket. And this is an auto-generated policy. You don't need to like have very good skills of creating policies. It's good to know, but you can always copy this. And you can give it, create a new policy and then assign it. So I have already done these 2 origins created. So basically now what this CloudFront distribution can route to any of these 2. But how the routing gonna happen? That you can define that if the URL is, if your path pattern basically is your CloudFront distribution / some.jpg or /.html, then route to this image only bucket. If your path contains HTML, then route to this. And if you don't have any such thing, you can route it to a specific default, maybe an HTML only sort of thing. This is not required. So how we gonna test it? We'll probably take this URL. Oops. I may have already done this. So I'm now browsing this /JPG, which is only available in my S3 bucket in the images side. Then I get this bucket. If I refer index.html, then I go to index.html. But if from your buckets, you will see that index.html is only in the HTML only bucket. So this sort of networking arrangement, or this sort of path-based routing, etc., can be configured using CloudFront and can route to different buckets. Now, this can give you multiple different scenarios. Right now, we are using only these buckets, but think of this as this deployment. This deployment, we can say, is for my customer X. So my landing page can be index.html, but it will have all the infrastructure and all the arrangements, logo, etc., with different theme for my X customer. This I can use a different routing and route to a customer Y. So if this could be a Infosys bucket, this could be a TCS bucket, and when my end customer logs in, he will see that Infosys logo is there. And you would have seen that some reward programs or some such websites will, when you log in, they will detect that you are logging in through Infosys endpoint, and it will have like my product, my company.com/Infosys/reward program. Then Infosys logo and other things will show up. That's how they create different S3 buckets. And obviously, these are just landing pages. Behind the scene, S3 bucket can then later on make other calls to EC2, EKS, and all to get rest of the information. So static websites are usually to give a landing page and then drive your customer from there. Yeah, Deepak, you have some question?
Yes, I have a question. Could you show us what's the difference we see on the screen when you make the bucket public and then make it private? Is it possible?
I didn't get that.
So when we keep the bucket as a public and when we try to access that same image, is there any difference in the URL or how we end users see that this
Yeah,
bucket is
so
public or
end
private?
user, you can control this. For example, right now we haven't created a domain for this one. We can always create like a Route 53 record pointing to this URL. So your customers can see something like your website/index.html and your website/images dot some image. Then they are basically going to two different buckets.
Okay.
And only your CloudFront distribution has access to these buckets. That's what the main objective, like what we want to highlight here.
Thank you, sir.
You can define different behaviors. You can have different sort of origins if you want to. You can create origins for your load balancers if you want. We have a couple of load balancers. So CloudFront distribution can distribute traffic to not only buckets, but also load balancers if you want to. Because not every application will be a sort of static website, right? It could be different possibilities are there. So let's see how that's done. So sometimes like this is a mixed content, again, two different behaviors. So here we have a CloudFront distribution. Users will connect to this, and we can have a behavior which says serve images from a static website. And we can have a different behavior which then sends traffic to my EC2 instances or my load balancer. Basically, there should be a load balancer between these two. But eventually, the idea is that Amazon CloudFront can also have load balancers as the distribution. This is also a very common sort of setup. Have static content from bucket, your images, logos, and those kind of things. Then they get cached near the edge location. Why I am not doing it live? Because this, you will, when you start doing it in your environment, you will see that this CloudFront distribution deploys its content, caching, and everything across all these different edge locations. So all that process takes time. And even if, for example, you update an index.html, it will take a while before that gets reflected. So it won't be very real time because that's get cached at each location. Even if you change index.html behind the scene in a bucket, it will take a bit of while, 10-15 minutes or some TTL time, and then it will reflect. So that is a sort of like some sort of limitation these CDN services have, but the advantages are that you can route it to different buckets and compute. And then there are other ways around. If you are deploying some new changes, you can always invalidate the caching so that it always looks for new information. Yeah, I will. You have some question?
Okay, I want to ask if CloudFront can also be used for dynamic contents
Yeah,
instead of static.
yes, it can be used. Right now we are using static content, but if you use it for behind a load balancer or something, then you can always generate dynamic content.
So in that case, does it still take time to reflect? Does the TTL also affect that since it's supposed to be real time?
Yes, so that's where the limitation. It won't be cached that well. The caching, etc., will work best with static content. With dynamic content, the caching will have its own limitations. So you are most likely gonna reach out to your origin to serve traffic or serve information all the time. Now this can get slightly more complicated. You can also run a Lambda function at edge. Lambda function at edge usually is a very small Lambda function which can detect what your user is trying to access and then can route to different buckets. It's pretty much the same functionality. But like there can be more additional functionality with edge, but here we did a sort of behavior where you can say //JPG or /HTML how they should be routed. You can also, when you are creating different origins, that in the when you are creating a sort of, when you're starting fresh, creating a new distribution, that's when you can define functions associated. These are optional. These edge functions you can define to this behavior. These are basically your Lambda functions. So you can write a Lambda function in US East 1 region, and then you can associate these different Lambda functions which make it slightly complex, but again, very popular use case. So for example, if my path has as a customer name or something, and I want to give him a welcome message based on that, my logos and my other stuff has to be properly for that specific customer, then I can run a smaller Lambda at edge, and then I can route to that specific bucket. It's basically the behavior modification, but through code rather than what AWS offers. So you can do different things. You can use a specific behavior settings, but Lambda at edge will give you much more power. You have basically, you are running a program close to the user. And within that program, you can do different things. You can read from database. You can query, say, DynamoDB or some other service, and then modify your web page or anything you want. So it is slightly more sort of powerful when it comes to defining different behaviors. It's should be usually lightweight, smaller Lambda, which detects certain information about the user, will detect that is the website or product being accessed from a mobile device or from Chrome or from Microsoft Edge. And based on that, we'll do certain basic modifications, not extensive computing and all, because it can be costly. Okay, these were some of
does this microservices architecture also follow the same pattern?
You can say in a way it is kind of similar, that you will have like an entry point into your microservices architecture, and
Correct.
then you can create different routes, but not in concept wise. Yes, very similar when it comes to the architecture, but the idea is very different. There
Correct.
you are
Yeah.
entering into a Kubernetes or a sort of microservices environment
Okay.
through an entry point, and then routing to different locations, different pods, etc. But this is at a global service level. But yeah, the architecture or the idea behind this is very similar. Okay, so we looked at briefly CloudFront distribution. Let's talk about a bit on Route 53 as well. So usually you will see in theories and other stuff that Route 53 is mainly a domain management sort of thing. That's what we saw. We saw that we can create different these hosted zone, etc., and we can create different records if we want to. But it has more slightly more powerful tool than that. It can not just a DNS service, but also has capabilities or policies where you can route traffic to different locations, different regions that you have deployed to. So Route 53 can do that health check for you, that if you have deployed your services in, say, US, UK, and Australia region, then you create a Route 53 record, and then you can configure your policies in such a way that it can send user to your closest region, basically. And also it can detect health check and that kind of thing. So let's see how this Route 53 routing works. So if a user is in US, he will hit a specific endpoint, and it will be routed to US. You have configured your application in US region as well as your application in European region. So a US user will, this is the green color. I'm not sure if colors are very evident in the screen share, but if this user comes through this channel, is trying to access this product in US, then he will be sent to the US VPC. If the user is through Europe, then Route 53 will send it to this specific VPC in your region. That kind of thing is possible. And how did I do this sort of setup? Okay, so to achieve this, I have created some sort of setup already, and I will explain you what I have done so that you are aware of how this is running. So I'm using two different regions. Now you have to be very attentive and like watching very closely what we are looking at. If you want to draw this on your side, have a pen and paper handy. And we have an instance in Sydney region. Now this the objective is to learn a bit of networking. So some of the concepts may not be following good practices. So I have a public IP address associated with this, and I am hosting a small sort of website which says this is the IP address of the machine. I think it's a private IP that it's showing, and it's hosted in the AP Southeast 2 region, which is Sydney region. 31. This is my private IP, which is 172.31.530. So this showing the private IP address and the region that I'm deployed into. I can always, for good practices, I can always create an auto-scaling group for this instance or this setup, all sort of that sort of thing. But what I have done is I have created a load balancer here. Created a load balancer, which is listening on just on port 80 and routing the traffic to a target group. I hope you guys would have done basic load balancer setup and routing traffic to an instance. So that is the sort of simple setup I have done. It's routing traffic to this target group, which has one instance, which is the same instance that we have, 628. So this is basically the web. This is host this. There is an ALB in front and then an EC2 instance behind it, which is healthy in nature. So I can also access my EC2 instance through this IP address, but I can also access this through my DNS record of the let me do it on a different window. So I can access the same instance. Private address is this AP Southeast region 2. Now I have done exactly the similar setup in a different region. I have done the same setup in US region. Exactly the similar setup. I have a load balancer in US, which is test US. It's sending traffic to a target group on port 80. And it is then sending traffic to another EC2 instance entirely in US region. To this instance, which is in the US East 1. And what does this print? This will print slightly different information, the private IP address, which is different, and this is in the US East 1 region. So now in order to achieve something like this, my users will access a specific endpoint, but based on where they are coming from, I can route them to different VPC, different TLB. So I am in route 53 now. And this is where I will use DNS plus certain policies. I have created a sort of record here. This is my record, global DevOps Cloud Labs homes. But its type, I'm using a sort of geo proximity location for US region. I'm pointing it to a US East 1 ALB. And I have a similar sort of setup for Australia region. I'm pointing to a load balancer in Australia. you know the difference between these two load balancers. This is this is a load balancer which is in US East 1. This is in Australia, and the messages that they print is different. This will print a message which says you are in US region. This is in the Australia region. So you can basically you don't have to remember all this. You can create a record. You can select different kind of routing policies. We should, for our this one information, we should be using at geolocation, latency based stuff. So latency is where automatically this load balancer will detect which is the best possible region my customer should have, and then automatically route it there. With geolocation, you can specify that my US region, US users will go to US load balancer, etc. You can say geo proximity is also similar in nature, where we are using its location, and based on that we are routing. So these are all pretty much similar sort of stuff. You can define your global entry point, and you can say route to certain AWS services and define your proximity record. That this is the record name, route to say load balancer in different regions. Sydney, we have this load balancer, and you can define to a specific region, and that's how you will. My Sydney guys should go to here. If health check, if you want to do, and I don't want to evaluate all that. And that's how I can define multiple geography based policies, which I have already done for this specific record. And then it will automatically create me these routing policies, geo proximity location, and I automatically am routing to different. So try to implement these things the way I have tried to explain. It's very straightforward. Most of your effort will go into setting up an ALB EC2 instance and that routing. Once that is done, then things will start to work automatically. So if I, for example, now access this specific location, because I am in Australia, I will go to AP Southeast 2. If somebody is in US location right now, they can probably give it a try and confirm that they should be, by pointing to this specific endpoint, they will be going to the US region, which is nearer to them. So if somebody can confirm it, otherwise I have a different way to test it. Somebody's in US right now can confirm me what
Maybe
they
just post the URL in the chat, Sunny.
Yeah, just 1 second. Chat. And also let's see what European and other people are also getting. I have posted the URL in the chat. Because I have only tested in US and Australia. I don't know what guys in India are getting.
Yes, it is working in USA.
And you get US East 1 region and a different IP?
Yes, US East 1 region and different IP. That's correct.
Thank you. How about in India? What do you get in India?
AP Southeast 2.
AP Southeast 2, which is Sydney, probably closer to you.
Yes.
Yeah. So that's the basic idea, that that you get routed closer to your location, and you can then set up these 2 or 3 different regions and play around with certain policies. So what I wanted to highlight was that Route 53 is not just DNS. It's not just that an ELB has given you a random DNS name, which is not very user friendly, and you can only say like my website goes to this. That's the DNS part. but then it has its own policies, etc., where you can route it to different regions as well.
Yeah, it's a similar thing like when you have Amazon and you go through Amazon.com and then it reroutes you directly to US or India automatically, depending on geo proxy.
And there are other type of policies also that should be tried. We should explore that kind of stuff as well. Then comes the another beast. So you can use this setup also for your, you can explain blue-green kind of deployment, that you can put health check when you are configuring. If index.html is not accessible, then you can always route everything to Europe. Even US users can Europe. If you set up a health check and your website is down for some reason, then you can create those smart things. Next, take a look at global accelerator. AWS Global Accelerator. So this is again a sort of edge service driven mechanism, but it is slightly sort of different. Let's go back to our theory that we discussed. So Route 53, what it has done is basically it has enabled that me sitting here, I can access a specific region through Route 53 records. Similarly, somebody in here, sitting here, or in India, a lot of people confirmed US people were routed to US East 1. I was routed to this region. They were routed to probably this, and these guys were routed to this, that kind of arrangement. But it was all over the internet. It wasn't still using the AWS backbone. So solution for that, what AWS recommends is using a global accelerator. So instead of you using just plain Route 53 routing over the internet, you can also bring in other additional thing to use an entry point to your services and still do this traffic routing, etc. So for example, you can configure your environment blue-green active passive environment into different regions: US East 1, US West 2. We are using Australia region for demonstration. This is an image depicting that you can deploy your environment to 2 different regions, and through health checks, you can define that my users will use a specific endpoint and will be routed accordingly. But over the AWS infrastructure, which means consistent results. All the time you are going to get similar sort of output. Let's take a look at this kind of setup as well. So I have, now again, when you create a global accelerator, it's a paid service and it takes 15-20 minutes because it gets deployed. So that's why I'm not doing it live, but it's very straightforward to do it in your accounts. Is anyone raising hand? Or I saw some hand raised and went away, but that's okay. Yeah.
Sanjeev, I have one question.
Yeah.
When we configure this Route 53 for multi-cloud zones, is there any possibility we can identify whether it's the application performance issue or the AWS the link issue?
When it comes to performance, you mean?
Yeah, correct. Let's say in India region or somewhere, anyone is accessing that application. And we need to identify whether it's on the application related issue or it's the link in between, because as you are saying, there is a back-to-back connectivity, right? Backend connectivity.
Yeah.
And another is the internet connectivity. How we can identify whether it's a backend connectivity or internet connectivity. It
It's
means
hard. It's very hard.
AWS, okay. AWS provide any service or anything?
Not that I am aware of that you can detect an application performance that, in that simplicity and get a solution. You can,
Because there are the third-party solutions where they provide hop to up means performance, like what is the performance or what is the latency?
there are tools that can detect this change in response time and change in performance and can notify you, but they cannot pinpoint that is it because of your application performance or is it really because of your infrastructure performance. That differentiation.
But with the help of AWS tag or somewhere, we can identify them or not?
Not that I am aware of, actually. No.
Oh, okay.
If somebody
Okay,
has
fine.
any idea and they want to add any thoughts that we are missing. How do we detect performance issues, whether it is due to network latency or
Can
whether
I
it is...
suggest?
Yes, please. Yeah.
Can you raise an instance at the same location and just bypass all the network and just directly access the bucket or the application?
That's a
something like
debugging
this,
thing,
maybe?
right? That's a debugging part that, yes, you can always bypass and hit that specific instance and ALB.
Yeah, this way you can detect if it's the application maybe or the network.
So as a next step, basically what is being suggested here is that you probably hit an ELB endpoint and access your instance. And if you see the similar performance, bad performance, then it's because of your infrastructure. If you see that user accessing Route 53 and then going to your specific region, then it is probably because of internet variability. But there is no tool as such which tells you all this automatically or monitoring.
Means real time, it can provide some telemetry, right? So that we can identify whether where is the issue, right? Okay, fine.
Okay, we were looking at another.
Yes, Sanjeev.
George, yeah.
Before you move on, I just wanted to get some clarification on that blue-green deployment. From what I understand, it's used and is used to maybe roll out maybe a new deployment or a newer deployment of a particular application.
Yeah.
And I'm wondering, the example you used was blue environment in one region and a green environment in another region. I'm just wondering, is this a real use case? Like, what would be the rationale behind, say, you have an application in the US and then all of a sudden you want to move it over to US West 2? Is this a real use case, or is that...
It is real use case, not for every application, but an application that requires stability in case of an entire region failure. If your application is mission critical, something like a banking application or some application that you actually want healthy in another region, then you deploy it across 2 different regions. Blue-green deployment has like multiple use cases. One is to test different version of applications across regions, and the other is failover. So you can basically, if this entire region goes down, you have another region set up. Routing traffic through global accelerator is like a piece of cake. You can always move it to different regions quickly.
Okay, so this is more like for failover disaster recovery purposes, not for the...
Not so much for testing. Yes, not so much for new additional rollouts, etc.
Okay, all right.
But the same concept can still apply. It's not that you cannot use this sort of setup for rolling out certain features. You can always do that.
Okay, thank you.
So here I have created a global accelerator. What it does is it provides you a couple of static IP addresses. So another use case where you will prefer GA is when sometimes, for example, let's say my application is hosted somewhere in US East 1. And just hypothetically, just let's assume that this connects that there is a third-party vendor somewhere in another region or another product or something, and then this connects to my AWS environment, say HTTP endpoint or something, and this company will have to route its traffic to my environment. They cannot whitelist or they cannot open traffic to my entire www.mywebsite.com. It's against their security. They just want one specific IP, X dot, Y dot, Z dot, something. They just want a specific 1 or 2 IP addresses to be whitelisted. In that scenario also, your global accelerator comes into picture because it assigns these static IPs to your service. So this endpoint that it provides is basically 2 static IPs are associated, which makes it very easy for third-party customers to whitelist you. So I have created a global accelerator. I have created a listener, and within those listeners, I'm listening on port 80, and I am using 2 different endpoint groups, Sydney and US. Basically the same sort of setup. If I look at these endpoint groups, if I look at the endpoint group in Australia, it is sending traffic to the same load balancer that I used, sending traffic to this one. So what it has done is, it has given me this DNS name, and this then behind this scene sends traffic to these multiple regions that I have, where I have deployed. Right now, just 2, there could be 10, 15, or how many regions that are possible. I can route it. Certain traffic percentage also I can specify. And basically, that's it. So what it does, again, the very similar sort of functionality. I can always can take this endpoint, this DNS name, and I get routed to my Sydney region. But if I paste this again in the chat and somebody try to access this HTTP endpoint.
Sanjeev, do we require Route 53 for this GA? No?
No, routing is already, we have done this in this setup.
Means Route 53 still be required, right?
We can, yes, we can have this. So this has given a DNS name. I can use this, or I can come here, create another record, use a simple routing maybe this time. I don't want.
Okay, basically GA purpose is to make the active passive scenario, right?
GA purpose is to provide an entry point into my AWS at an edge location closer to my where my users are.
Okay, and we can whitelist certain IP addresses also, right?
Yes. So the objective is that with this is the same setup as this one. There's no difference. This is going all over the internet, so your response time will be dynamic. This is the same setup going across different regions, but using AWS accelerator, which means AWS network. So
but it's our choice whether we can use the GA or means GA. When we are using GA,
Yep.
It's not mandatory to go with the Route 53, right?
Yes, Route 53
Okay.
policies. Yes, it's not mandatory to go with that and this. It's up to you. We'll discuss that, which one to choose.
Okay. Okay.
But can someone confirm that if they hit the same URL in US, they are hitting a US endpoint?
Yes, it's pointing to US East 1 region.
Thank you. That's what we wanted to confirm, that me sitting in Sydney, this URL will give me Australia, and somebody in India will be routed to Australia. But it's a different mechanism. We are not using that global endpoint that we were
I mean,
doing with
Nigeria, and it's pointing to the US.
US. That's closer to US, yeah. Only I think India and Asia Pacific guys will be sent to Australia. Rest of the people in Middle East, Europe, Africa will probably go to US and also US.
Yeah, Middle East is routing to US.
Yeah.
And one more thing, can we use this global accelerator IP in the reverse order, saying like API, we need to hit to an external third-party service where the service IP should be whitelisted in the third-party level.
Yes, we should be. I haven't tested this, but I don't know.
Because that may be the normal use case. We are calling a third-party service, which is some legal entity or sort of, where we need to whitelist our service IP. And in API gateway level, it's internally invoke lambdas.
Yes.
So
Yes,
it will get
absolutely.
all
Yes.
the IP pool, whichever is for that specific region. And we will not be able to whitelist all this set of
Absolutely.
thousands of IP.
Absolutely. That is the use case, that you want to provide these IP addresses to your users, which will not change, which will be static in nature or throughout the life cycle of your service. And you saw that we hit this IP address, we still hit the US region. So you can host, if your company has limitation that they want to whitelist only specific IP addresses, not all the stuff, but then your accelerator setup will become slightly like it has to be smart. For example, you will. This is a very simple sort of setup, listener. This endpoint groups becomes very sort of complex. So for example, multiple regions will make this. Then within this multiple regions, your entry point will be one load balancer. You don't have much path-based routing and all those sort of things. Once you land at your application load balancer, you can then add more path-based routing, and because now this is your entry point, global accelerator to your load balancer. And then your load balancer has to be smart enough that, for example, /API calls have to go to a API target group, which can be EC2, which can be a EKS cluster. All your /images have to go to a different load balancer and stuff like that, or different target group. So there would be bunch of such target groups, bunch of such rules, which will say that if your request is of this type, go to this instance. That's the idea.
But so okay, this for inbound traffic, right? Can we
Yep.
use it for outbound? Saying like
Yes.
an internal lambda or a service, you need to hit outside.
Yes, yes.
And,
You can use this, yeah.
but an API gateway can't be linked to an accelerator.
API gateway, if API gateway can be behind a load balancer, then yes, otherwise no.
API gateway behind a load balancer, then first the traffic will hit the load balancer, then it to API gateway in that
Yes.
manner.
Yes. Yes.
But API gate can be linked to a load balancer.
Then you can always use global accelerator, ALB, API gateway, and your Lambda or any other such thing.
But all these things are for inbound, right?
Yes.
Outbound, we can't link anything to API gateway other than Lambda.
I'm not sure. I'm not getting.
So he's taking a scenario saying like we have an API,
Mhm.
it's like a
API will
AKS
usually be
service.
sending a response, something like a JSON response, etc.
Yeah, I think in a situation where there is an application is deployed in EKS
Mhm.
and it's invoking an external API through the AWS API gateway, where the external third party required an IP to be whitelisted.
Yep.
But in this scenario, API gateway will be always giving the dynamic IP within the AWS series.
Yep.
And the third party is required a static IP. How we
Yep.
can address this scenario?
So you will be sharing this specific IP with your customers that you hit this website, this one, right?
No,
Say
this is for inbound, right? Saying like if we need to access this API from outside,
yeah.
this is the inbound IP.
Yes.
But the API, the internal API within this server account need to hit a third party outside. That'll be an outbound connection. This won't be the IP. How we can get a static IP for an outbound connection from an API gateway?
There is no static IP address for inbound and outbound. It's the same IP address that will be used by your customers. If your concern is that an API gateway or some other service within AWS can be dynamic in nature, then even this EC2 instance that we are having, this can be dynamic. The IP address fixed with this.
But we can put an elastic IP bind it to the.
Yes, that's how you will do it. That's how you will. We're not even using an elastic IP in this case. So your load balancer, if this can be an automatic auto scaling group, number of EC2 instances can go up and down. But your load balancer in front will make sure health checks and will send traffic to that. So that within a specific region, identifying the health checks and doing routing, etc. within a region is basically done by the load balancer. And it is when it comes to across different regions, that's where accelerator will come into picture. So there is no such thing as like a static IP address assigning to your EC2 or API gateway. That is within your region, those issues, those challenges we have to resolve. How do we, like even in case of auto scaling group or any other service, that dynamic nature will have to be managed. But once you have done that, you're across multiple regions, this is how you will do it. So you will share that this customer should whitelist this specific IP address on their side, whether it's for inbound and outbound. So they will allow calling this IP address and receiving information from this IP address. And then they will be calling us, say, /API. Then /API will hit first the global accelerator. Then it will detect that this is for Australia region. Let me send it to Australia region load balancer. Within your load balancer, there should be a path-based routing rule which say /API go to this EC2 instance or this API gateway or this EKS cluster. That will generate the output for you. Then load balancer will receive that information. Then GA will receive that information. Then your customer will receive that information.
Okay, let me try it.
Yeah.
Thank you.
Just that right now we are using this sort of setup, but it can be an API or anything like that. But yeah, do try it out. And next week we'll do it for like you guys presenting anything that you have implemented, and that sort of will keep a session for interactions and anything you have enhanced this solution or your learnings, etc. So we can do that. So sorry. When to use which one? So we saw that which one to choose. Both these Route 53 and GA do the same sort of stuff. So when to choose which one? Basic concept is that in case of a user using Route 53, we'll be doing it over the internet, which brings very dynamic sort of nature. But a user first gets to a global accelerator endpoint, then all the route traffic is routed across GA, AWS network backbone. Then it's very consistent in nature. It doesn't mean that this will be faster than this internet. This can be slower as well, but it will be consistent. So this is the sort of difference at high level. Route 53 can give you variable results. This will give you consistent results. Which one should you be using? That is the most important question. So the short answer is, if you have like multiple regions defined, if you have just 1 or 2 regions defined for your users, just like in this small example, it's better to go with a GA kind of setup, because then GA will deploy it across closer to your users, and it's easy for your users to get into that and get consistent results. But if you have deployed your application in, say, 10 different regions, then you want that user to be accessing the closest possible region for you. And GA may not be the absolutely perfect solution for that. If your application is deployed into quite a bit of regions, then you will look at probably Route 53 based latency or geography policies, etc. That's the usually suggestion. You will look at where your users are located and how many regions you are covering. Based on that, you will select which service to use. I hope there's no standard answer or stuff for that. So for example, if you are if this is the sort of network and you are only deployed at this location and this location, then you let GA do the magic and make your users enter into specific GA, because you have only deployed it in a couple of regions. But if you are deployed in all the regions or many of the regions, then make use of the Route 53 geo proximity policies or latency based policies, etc. Now comes the bigger challenge, how we easily managed these demos, because these were like simple application, probably an API or a static website or that kind of thing. But most of the enterprise applications will have a database involved. And that database is where is probably the biggest issue in the all multi-region setup. Because if you try to go for a high availability kind of setup, then your consistency is you cannot meet all the consistency requirements. Basically, the idea is that if this application had a database, and if users were writing into a database in Australia region, the US region will get an out-of-date information for quite some time until the data replication happens, and then you get a consistent result. So if you go for multiple regions for high availability of your applications, your consistency will get a hit. And similarly, your if you go for the other way around, if you go for a high consistency that you want everybody getting the same view, then you cannot go for a high availability kind of setup. So this is a CAP theorem you would have probably studied in your graduation or your education time frame. So you cannot get all the 3 pillars, consistency, availability, and partitioning at the same time. And you need to have a right balance between them. And database plays like the biggest spoil sport when it comes to designing multi-region applications. You really don't know how to manage your database. What are the solutions of that database? Basic RDS or basic Aurora sort of thing is not feasible, like not very, cannot sync the data easily. You need to implement custom data replication across regions. So something is being written in your Asia Pacific should be replicated into your different regions, US automatically, very quickly, and your DBA can configure that kind of connection between these regions. First, they will achieve peering and then data replication settings in, say, Oracle or Microsoft SQL Server or Aurora or other such databases. What AWS offers is a global database, which automatically does this behind the scene. So you will get an endpoint which your US users will use, your Australia users will use. Basically, it's a connection string in your application that will be used, and behind the scene, the replication of data across regions, AWS manages, but obviously they charge very high price for this. And you can look at global database. You can also look at DynamoDB global tables for any sort of config or any such small data that you are managing. They also do the similar sort of thing. So you can configure a table in, say, Asia region, and then you can replicate it to US, and anything returned to Australia will be replicated in US fairly quickly. And then you can look at complex scenario of sharding your database. People use it with MongoDB and other such databases, but again, it gets quite complicated. Sharding at very high level means that you are storing different copies of your database. Your Australia region database is stored a copy in Australia region. Similar sort of setup, similar schema, but your US users are using users' data is stored in US shard. And they, again, keep replicating that data over a period of time with a bit of latency. But your users, if your application is designed in such a way that it needs only Sydney specific data in real time, and then US data can take a bit of time, then you can use this kind of arrangement as well. Very large applications will use this kind of sharding. Yeah, you can look at Aurora Global Database maybe as an example and try to configure this and set up. The RPO and RTO are usually very low in this. You can recover in case of a disaster in a specific region. The other region can stand up very quickly. You can get it done in minutes, and also your data loss is very minimal. Like you can expect it to be in very seconds. But to have this kind of RPO and RTO, you are gonna be like AWS gonna charge you quite a bit. So these are some of the concepts, the routing stuff across different regions. What are the possibilities? What are the database possibilities? What are the networking possibilities across different such services? I created these demos today. Takes about a day to achieve all of them. So I would suggest you guys try to implement this. I would highly recommend that everyone try to achieve this kind of setup that we have done across session 1, session 2, session 3, and today's session 4. First is we try to configure our multi-account setup where we are trying to use control tower. Second, we try to create sort of Packer-based and Terraform-based infrastructure. Packer is to get an EC2 image. And then using the Terraform, we try to deploy EC2 instances across dev account, QA account, prod account in different regions. Once we have deployed, say, a prod account or a dev account or QA account, then within that specific account, we try to create region 1, 2, 3. I did 1 and 2, US and Australia. You can also experiment with a UK region. Within that, using Terraform, you try to deploy VPC. Within that VPC, you deploy an EC2 instance, which prints, I am in US, I am in Australia, I am in UK, and make sure that you have a load balancer in front. This becomes your regional networking concepts. Within region, what you can do, you can always access your website ALB endpoint, and it will point to an EC2 instance. It will always say that I am in region 1. You can never get in region 2 because that is a different ALB. Then you use services like CloudFront, Accelerator, Route 53, route traffic to these different ALBs across regions. You can define GA, these regions as your target. You can use Route 53 proximity, geo proximity, latency-based policies to route traffic to these, and you can observe the endpoint that you are getting, how different users are behaving. And you can use CloudFront for your static websites and also for your dynamic content from an ALB. You can also create similar sort of things, and you get an idea that CloudFront and GA are more of closer to the user in terms of edge location, whereas this is over the internet, slightly dynamic behavior, but they do the same purpose. You need to understand in which scenarios you're gonna be using them. That's pretty much at high level I wanted to cover in today's session, and this is at very high level, like what we have understood in all the 4 sessions so far. I would suggest that you guys implement these small projects in your accounts, come up with issues, face those issues, learn from those issues. That's how typically a sort of a SaaS setup, a company setup will be there, where we will be looking at multiple accounts, deployment of standard images in different regions, and then routing, different possibilities of routing over the internet to my specific VPCs. And in that process, maybe a blue-green deployment is one of the possibilities. So yeah, that's pretty much wanted to cover. And what I'm thinking is that when you guys implement it in your account, next week we will have some demos. If you guys achieve this, you guys extend these solutions in your accounts, implement something which we have just discussed but not shown you, or from your experience you want to add any additional points. At the same time, next week we will see how you can build a story around it, how you can explain last 5-6 months or 1 year of experience and show that what you did in this project, how you can explain that sort of storytelling, sort of how you have to, what language you should be using in your resume, in your LinkedIn, and in your interviews. That sort of storytelling is what we will discuss in the next week's session. Any questions on this? I didn't want to deploy a Kubernetes cluster or show that functionality. We wanted to understand. Compute can be anything in this case. Compute can be a EC2 instance hosting a basic stuff. Could be an API, could be Lambda function or Kubernetes cluster or ECS cluster. Anything can be used behind the scene. It's basically you want to hit a load balancer and then you can drive your traffic. So you can have any sort of rules and regulation there. It's mainly how you hit that load balancer, which is in different regions. That is that level we wanted to understand this. Within a specific region, load balancer can be used for EKS, ECS, auto scaling group. That's within region. A lot of examples online will be available, or basic routing is possible. It's the multi-region that I have seen people not knowing enough or not having that understanding and not doing those hands-on as well. Any questions? And the benefits will only be coming if you do it in your account. You will probably learn better. Just watching it, because I did this setup in 3-4 hours today. I expect you guys do it, then it will make more sense. Right now it's very superficial at very high level. I have tried explaining what I have done, but you will see that some of the things like a policy being applied to a bucket, or making sure that the buckets are not public in nature. Your CloudFront distribution has access to your buckets. Those sort of things, you will get into issues. You have to try those things, do it yourself, and understand the very low level stuff as well. I'll take a pause and will allow any questions before we close this session.
Looks like no questions. A great session, Sanjeev. So full of information.
I have one thing just from previous session that Sanjeev actually showed us a spreadsheet about the AWS control tower controls. Can you please put it in the group so that actually we can...
That spreadsheet was not from the control tower. Actually, control tower does not give an export functionality. That was one of our, actually couple of our mentorship students, I think Ram and Aman. They sending a spreadsheet from the well-architected framework WAF.
Yeah, okay. If it is possible, then can you please give it to the group?
Yes, I will paste that in the group. And when you are reading that, make sure that you guys are at least understanding 5 to 10 different good practices in that, especially around buckets, EC2 instances, maybe load balancers, that you can take in your interviews. That for ELBs, access log should be enabled. Buckets, encryption should be enabled. For EC2 instances, public IP should be disabled. Public IP should not be allowed. Those kind of good practices, and take it in your interviews. I'll paste that as well in the.
Okay, thank you so much. Yeah, that's why actually I am asking for.
Yeah. All right, guys. Next week, the expectations. I'm not delivering anything. I'm gonna explain how we show this, use this project as an experience, build that story. But any demo, anything, it's your opportunity. You guys can bring demo from your environment. You may be using GitHub Actions to create Packer-based images. You may have tried different things, or you may have done exactly what I have shown you, but try to showcase, bring it, any additional learnings, etc. Yes, Ram.
Yeah, I'm sorry, I missed the first part. I joined. I hope I will pick up from the recording. One thing I ran into issue was when I created. I had created the organ, control tower and landing zone and everything. And what I did was I thought I can recreate. I because I missed one of the OU. So I thought I can easily recreate it. What I did was I decommissioned the whole landing zone, and when I try to recreate, and hey, you have some resources, you should manually clean up, and I try to clean up some of the whatever it is created, but except I'm unable to create a security account under one of the OU. And
if you missed out some OU or some account, then you don't need to create control tower again. You don't have to clean up everything. You can always invite those accounts and you missed out stuff.
So you are saying just create organization and go from there, just invite those accounts instead of having, but I won't have those guardrails, right? That's
you will have everything. Why not? Usually it doesn't mean that any of the product that you use, you will be using it on day one and otherwise you can't use it. No, you can always, I think people, there is an option and people did mention that they were able to achieve it. You can always invite existing AWS accounts under that.
Right. My question was because in the control tower deploys some of the some of the preventative
Yes.
and detective and I think another category. I don't remember. It enables those controls, in the organizational level, OU levels. I won't have that if I don't have the control tower, right? So
yes, if you don't have control tower, if the
that's what
account is not
now I did.
enabled in
Right.
control tower,
I decommissioned the control tower totally. Now I don't, it's not allowing, I will, but I found a documentation to clean up some of the, but it is using the CLI commands, but I have to install the CLI and then maybe I will try to clean up and recreate if possible.
it can get complicated. Even one of my account, I cannot, its cleanup is done from my side, but still there are certain hanging resources.
Yes, right. That's where maybe I need to use a different account or something. Anyway, that's
If
fine.
it was an organization, you can always raise a support ticket and get support from them, and then they will probably go deep down. But because I'm using basic support, I am
Me
not
too.
able to raise a ticket.
I sent a ticket and then they said we cannot clean up for you because it is some of the reasons. They have reasons. They don't touch anything in your
And
assets.
they might not have access to it. The support you have is for your master account. You have
Right.
security and logs account, which even support will not have visibility of, so they can't do anything.
Okay, no
So
worries.
right now your options are, you try to look at the errors and try to use the CLI to clean up if something is missed out.
Right.
If that doesn't happen, your best bet is that you create it in a different account.
Different account. I think that's okay. No problem. Thank you. I hope I'll be able to go through this recording and learn. I missed the first part. So
yeah,
thanks.
Yeah.
It's a good session, Sanjeev. It's very good.
It's hard to bring it live. I tried doing it last time, but either we doing it live, I will miss out on some steps under the pressure of so many people watching or that kind of thing. Or sometimes these GA, the CloudFront distribution and even the ALB, creating them takes 10 to 15 minutes of time every time. So if we have to create 2 ALBs, GA, CloudFront distributions, it would have probably taken 2-3 hours doing the entire thing. So you guys do it in your environments, and then let's see how it goes. Thanks, guys. See you guys on next Saturday, 4:30 p.m. IST. And it would be your opportunity to show some demos.
Thank you, Sanjeev. Great session.
Hey, thank you. Thank you both.
All right, see you guys.